Hi there and welcome to EUMETSAT. My name is Mark Higgins. I really hope you've enjoyed looking at how we use weather satellites for monitoring the Earth system during the course of this week. I'd like to turn to some of the questions that you've been asking during the forum. We'll start with a question here from Simon. He's asking about how do altimeters work. So what they're doing is they're sending a radio wave from the spacecraft down towards the ocean surface and back up. We know where the satellite is, and so we can actually monitor the time, and from that time, that travel time, we can then get a distance. And that tells us where the surface of the ocean is. If we build up that record, of course, that lets us monitor the changing sea surface heights. Simon, in his question, suggests it could be lasers, and yet you do get some things that, of course, measure distance with laser. With a spacecraft, it's much more efficient to use the radio energy. Simon also carries on to ask what causes surge, which is quite an important thing. So surges are caused by a combination of three main factors. You've got wind waves on top of the ocean. You'll have a tide, which can, of course, raise the height of the water. And when you have a storm coming, storms are associated with lower pressures, which also allows the water to rise a bit. And so those ingredients coming together, that's what enables you to have a higher level of water than you'd otherwise have. And when that overtops your storm defenses, that's when you have a dangerous surge. And that's something that surge forecasters look out for. David asks about one of the images we have in the image gallery, which states that you can measure the winds aloft from satellites. Now, we can't measure those directly. What we do is we look at how the clouds move, and from that we infer wind speeds and wind directions. Now, because we can actually look at the temperature of the clouds, we can also assign some of that to height. So partially, we get a full 3D view of the wind field, which is really useful for putting into the computer models of the atmosphere to make them even better. Patricia was asking about cross-checking the evidence and asking if it's possible from the surface observations, the in situ observations, to get things that we can't measure from the satellites. That's really true. These two things are completely independent, and we need them to be independent so that we can make a proper, honest comparison between the satellite data and the in situ data. And there will be things in one of the measurements that aren't available in the other, which of course makes life really interesting. And particularly in this case, with the surface data from observations from ships, we get a much richer view of what's happening locally. So as Hayley points out in her answer to this question, you might also get some information about, say, fish prevalence and that, which you can't see from the satellite. And bringing all of this data together is what helps us build up a full environmental picture. I'd like to finish by just looking at a situation that was occurring just before we started this course. So we had a very active hurricane season this year, and this is one still taken from that moment, where we have 3 hurricanes across the Atlantic. Katia, which has formed in the Gulf of Mexico and goes on to affect Mexico itself. Hurricane Irma, which travels through the Caribbean and up through Florida. And then Hurricane Jose, which actually causes quite some damage to Puerto Rico before it then travels north through the Atlantic. It's a very active storm season, a very damaging storm season. And so just from this one image, you can see just how much energy there is in the atmosphere and how important it is to monitor these kind of storms. Now, the Hurricane Center in the US are responsible for all this forecasting. They would have been looking at all of the data you've looked at during the course of the week. So the scatterometer data, the altimeter data, the sea surface temperature data, to see what these storms are doing now, what the environment is like around them, so they can forecast what's going to happen next. So it's quite an important area. But we're going to change tone now for this week, and we're going to look at ocean transport, the dynamics of the ocean, and how the whole three-dimensional ocean moves. We'll look a little bit about salinity, and later on in the week, we'll look at ice and icebergs. Do carry on posting in the forum. It's tremendous to see all your questions and all of your answers, and I'm really enjoying seeing that, and I'm looking forward to seeing you in the next roundup video. Enjoy the course.